Hello, boys and girls. Let us continue with this circular motion. Today, I am going to elaborate on radians. Yesterday, we had discussed in short that what is radian. So, radian is also kind of angle. Means, in a simple word, angle is defined by two words. One is in degree, one is in radian. These two are different, but there is an interrelation between these two, which we will establish today. So before going into radian, let us discuss on why. Let us discuss on how the pi has been deducted. The value of pi. Pi you might be knowing. Pi is a Greek letter and it is expressed this way. How this was deducted, how it was brought into the picture and how it was derived. So for the mathematicians, while they were working, they draw different circles of different radius. This is, let us say, number 1 circle, this is number 2 circle, and this is number 3 circle. Accordingly, the radius of the circle has been named as R subscript 1, R subscript 2, and R subscript 3. So what they check, they just cut this and measure the arc length of the entire circle for R1, for R2, and for R3 radius of the circles. So while doing this, what they got, the total arc length from here to here, is for the complete circle. For this circle, for number 1 circle, for number 2 circle, and number 3 circle, when they divide the total arc length of each circle by its diameter, is 2r. The ratio was coming same, equal. It means if we say for number 1 circle, this was cut, spread on a scale, measured the entire length of the circle, and let us say that came as L1. They divided with diameter, means 2r1. R1 could be measured, so double that is 2r1 for number 1 circle. For number 2 circle, similarly for number 3 circle, when they divided, they got this L1 is 2r1. L1 divided by 2r1 is equal to L2 divided by 2r2 is equal to L3 divided by 2r3. These all were had the same value. And this value they have given the name of pi, because this ratio for any circle, the entire periphery length divided by the diameter, the value was coming about 3.1415 and all that. So means this ratio were constant for any kind of circle, and the constant value was this. So this was given a name of pi. So from here we got the value of pi. So for any circle of radius r, if you want to measure this entire length of the circle periphery, and you write it as L and divide it with 2r, it will come the same value, is equal to pi. So your length of the periphery is 2 pi r. So this is the way 2 pi r, the periphery length, has been obtained in mathematics. So now you know the length of the entire circle periphery is 2 pi r. So this is the arc for the entire circle, correct? If we take the complete circle, from here come back to the same point is the arc, the biggest arc for the circle, and that arc length is your 2 pi r. So to define radian, they define by saying that arc length of a circle if we divide it by the radius of that circle, so this is your theta, means angle in radian. So this is the way the radian has been obtained. If you take for the complete circle, so what will be the arc length for complete circle? Arc length will be 2 pi r, because from here to this point it is 2 pi r length. Divided by the radius r. So for complete circle, the angle from here to complete this, if you is 2 pi in radians. This is also an angle, the radian, the way it has been defined. So this is 2 pi radians. And what is the degree? So what is the value in degree for the complete rotation? If you measure the angle from here, complete rotation till, let me write this way. In degree, if you write, what is this angle? This is 360 degree, you know. So we can easily interrelate degree and radians by saying 2 pi radian is equivalent to your 360 degree. It means 1 radian will be 360 degree divided by 2 pi. So this is equal to approximately, when you put the value of pi, 57.3 degree. So 1 radian is equivalent to 57.3 degree. In a circle, if you're not having this value 57.3 degree, and somebody asks you to make 1 radian angle with respect to this line, this is your center, this is your center, and this is on the, this point is on the circle. So how to make this? If you notice, radian has been defined as, theta radian has been defined as r plane by radius. You want to find 1 radian. Okay, fine. How can you bring this value to 1? This ratio value, how can you bring it to 1? So you can say when arc length is equal to the radius, means your arc length is equal to the radius. So then we will get 1 radian. So it means if you get an arc of length r, here to here the length is r, if radius is r, then this angle will be your 1 radian, because r by r you are getting 1 radian. And if you measure it in degree, it will come to 57.3 degree. Now the questions for the conversion can be tackled having this information with us. If somebody asks you the value they give, n radian, convert this into degree angle. Convert to degree. So it is easier for you. You know that 1 radian is 360 degree by 2 pi. So n radians will be, if you want to convert n radians in degree, will be n times 1 radian, and that 1 radian is 360 degree by 2 pi. So simply multiply with this value. So you will get from radians to degree. Put the value of pi n and you will get the angle in degree. So for any radians, if you want to convert to degrees, simply multiply with 360 degree by 2 pi. What to do for converting degree to radians? You will just have to reverse it, right? So suppose you have, or suppose you have been given n degree angle, n degrees to convert in radians. Both of these are angles, huh? Degrees and radians both are angles, as we said in the beginning. So if you have to convert now n degrees to radians, n degrees will be equal to, just reverse this, just flip this. 2 pi by 360. So if any degree, if you multiply with 2 pi by 360 degree factor, it will convert to radians, equivalent radians. Some people may prefer that 2 pi by 360, they will cut to pi by 180 degrees. So it is up to you which way you want to build up the way to handle it. So this is for conversion from degrees to radians, and this one is from radians to degree. You might have noticed that 1 radian is 57.3 degrees. 57.3 part of the degrees means radian is much bigger than unit value of the degree. Let us go and solve the next problem. We can do one question on it. To get the feel further. Convert the following angles from degrees into radians. 30 degree, 30 degree to radians. What will you do? Simply have to multiply this 2 pi by 360 factor. Pi by 6 radians. ,90 degree. 90 degree to radians. Okay, 90 degree to radians. 90 degree multiply with this factor 2 pi by 360 and you will get that for 105 degree to radians. 105 multiplied by 2 pi by 360 7 pi by 12. So this was the question in part A. Now we should go for part B, where it says convert these angles from radians to degrees. How much radian? First one is 0.5 radian. This will be equal to multiply this with 360 degree by 2 pi. Just flip the above. You can do the calculation. You can put the value of pi as 3.14 and you will get a degree. This is your degree unit. Should be very clear in your mind. Degree is radian. Radian is unitless. It does not have any unit. These degrees or radians which is being called is just a kind of name it has been given to it. It does not mean that it has this unit. But to identify it internationally, it has been given a name of radian and degree. Same way for 0.75 radian. 360 degree by 2 pi. You put the value of pi 2 and cut and then whatever value you get will be in degrees. You can do the calculation. Pi radian. pi into 360 degree by 2 pi, 180 degree. Pi by r radian. So pi by r into 360 degree by 2 pi. Pi and pi is cancelled, so 360 degree by 2r or 180 degree. Make it 180 degree by r in degrees. Must write degrees radian for identification what we are doing. Let us go for part C. Express the following angles as multiples of pi radians. 30 degree to convert into radians. 30 into 30. So this is pi by 6 radians. This is what they want in answer. 120 degree. 120 simply multiply 2 pi by 360. So this is 2 pi by 3. 270 degree. 3 pi by 2 radian. 720 degree. 'So these are the answers. So this question had been given just to get a feel like how you can change radian to degrees and degrees to radian. But main thing is that you should know the concept, what is radian and what is degree and how it is different from each other. Both are angles. Since pi has been defined to know, like if you go further deep into the definition of radian. So definition of radian says, like, okay, let us say this is theta, okay, theta. So if you want to know the arc length, and your angle is known, suppose it is given in degree, theta degree. Then convert this to radian first, equivalent radian, and let us that is theta 1 radian. And now if you multiply this with r, theta 1, you will get the arc length from here to here. How it has been achieved? By definition, simple. Theta radian is equal to arc length under this theta radian divided by r. Since we are writing here theta 1, so let us see theta 1 radian. So you will get arc length is equal to r into theta 1. If r is in meters, so simple cross multiplication. So if a circle radius is given and an angle, and the angle is given in radian, not in degrees. If it is in degree, you have to convert it into radian. Then you can easily get the arc length for that corresponding arc length you will get. So this radian has been discovered for this purpose, so that we can easily know the arc length if the angle is expressed in terms of radian. So I hope the elaboration on radians is clear to your mind now. This was the request from few of the students from abroad. So they asked me to elaborate on it. So I made it a presentation. I hope the doubts are cleared and you have a very clear, crystal clear ideas about the radian. Just most important thing for to know the radian is defined as radian. First, it is an angle. It is defined as arc length under this angle divided by radius of that circle for which arc length is being discussed. So this is the crux. If you know this, you know each and everything. Other part is just an elaboration. Like when you do the make use of it, it will get clearer and clearer to you. But this is the crux which you should keep in mind if any time you get confused. So you can use this and can reach to the right solution. In the next lecture, we will cover the steady speed and changing velocity. Thank you.